Hello everyone. Welcome to the second part of differentiation. Today's agenda is to learn chain rule. So let's see what is chain rule. Before that, before starting chain rule, I just wanted to tell you few things what we know till now. So we know that if y is a function of x, then we differentiate y with respect to x. Okay, and then that is written as dy by dx as d by dx of f of x, or you can write simply as f dash of x. For example, suppose a function is given. Let's see, y is equal to uh, 4x cube is given. Then its derivative, when we will differentiate it with respect to x. Okay, then dy by dx will be basically, here 4 is what, 4 is a coefficient, so derivative actually doesn't apply derivative on coefficients. Okay, so it will be written in this way, and this will be 4 times 3x square, because we know that by using this formula, x derivative of x raised to n is basically n x raised to n minus 1. Okay, so this, till now we have done this kind of problem. So suppose, okay, suppose a function, okay, y is written in the form of another function. Okay, then what to do in this case? In this case, we have to differentiate this function with respect to u only, because this function is written, okay, this function is basically written in the form of u, so you have to differentiate this function with respect to u only, and therefore its derivative you will write dy by du, and here this side this will be again same thing, d by du of f of x. Understood? So what happens sometimes, uh, sometime in the question is not written simply in this format. Okay, and we wanted to find out derivative of derivative of given function with respect to x only. Okay, and in those cases, in some cases it is directly not possible to differentiate them. So in those cases we will use chain rule. Suppose your function y, suppose your function y, now here I am writing statement of chain rule. Okay, suppose your function y is written in the form of u, and you wanted to differentiate it with respect to x. Okay, in that case, what we will do, what is generally done, first we differentiate this function u with respect to, okay, take it in, write it in this way: y is a function of u, and we wanted to differentiate it with respect to x. So directly it is not possible, because function is written in the form of u, and we know that function we can only differentiate with respect to u only. Okay, so in these cases what we will do, we will first differentiate this function with respect to u, and then we will differentiate u with respect to x in this way. So dy by dx we can find out, first differentiating function with respect to u, and then we will multiply with derivative of u with respect to x. Okay, so this is totally different quantity, and this is totally different quantity, and total of this will give you, total multiplication of this will give us derivative of y with respect to x. Okay, so our y was written, and this is known as chain rule. Okay, so chain rule give us a kind of solution. Suppose y is your function, and it is written in the form of u, means it is a function of u, and you wanted this function of u differentiate with respect to x. Okay, in these cases we will apply chain rule. Now let's see few simple examples of chain rule. So here I am writing chain rule. Suppose y is written, here I am writing y is function of u, then basically its derivative with respect to x will be df of u. Okay, df of u we will differentiate with respect to uh, u, and into, then you will differentiate u with respect to x. Okay, now let's see few examples. So first one, okay, let's see example. Suppose you have y and it is written x plus 4 power 6. Okay, so in this case, uh, one way is very simple. Just use Pascal triangle. With the help of Pascal triangle, and you can expand this bracket, and whatever you will get, then you can apply this formula x s to n whose derivative is n x s to n minus 1. Either is that way, or you can simply use here chain rule. Okay, so for chain rule, let's assume that this bracket x plus 4, okay, this x plus 4 is u. Okay, assume that this x plus 4 is u. Okay, now differentiate this u with respect to x. Okay, so this will be differentiate. Okay, differentiate u with respect to x. Therefore its derivative du upon dx will be what? Derivative of x is 1 and derivative of 4 is its constant function, it's 0. Therefore its derivative du upon dx will be 1. And now when you will take x plus 4 equal to u, then y will be what? Y will be u raised to 6. Now y is a function of u, and now differentiate y with respect to u. So differentiate y with respect to u, then you have to use this formula, this one. Okay, so this will be what? Dy upon du, and 6, because value of n is what? 6. 6 2 raised to 6 minus 1. So this is basically dy upon du is 6 u raised to 6 minus 1, that is. Okay, so now, but at the end what I wanted derivative of y with respect to x. Therefore it, by using chain rule, therefore by chain rule, this will be du, it will be what? Du upon d. Okay, this is function of u, so df of u. Okay, or we can say d, no, it was right, du upon dx into it will be dy upon du. Okay, and this you can write, uh, means in the original format, dy upon dx, it will be dy upon du into du upon dx. Okay, this is one and the same thing, just I have changed the places of them, because this is its standard form. Okay, so this will be what? This will be basically 6 times u raised to 5 into derivative of u is basically here 1. So here it will be 6 times u raised to 5. Okay, but value of u is what? Original value of u is x plus 4. So now substitute this. So it will be 6 times x plus 4 power 5. Okay, I know you might be confused. Let's see another example to clear it more. Let's see another example. Suppose question number 2. Suppose y, you have 2x plus 3 and its power is 8. Okay, so again let the inner part 2x plus 3 as u. So let u is equal to 2x plus 3. Okay, therefore what will happen to y, which will implies that y will be basically equal to u raised to 8. Okay, now since u is written in the form of x, so therefore we will differentiate u with respect to x, and y is written in the form of u. Therefore we will differentiate y with respect to u. U is written in the form of x, that's why I am differentiating it with respect to x, and y is written in the form of u, and therefore it is getting differentiated with respect to u. Therefore here du upon dx will be basically 2 is coefficient, derivative of coefficient doesn't happen, derivative we cannot apply it on coefficient. Derivative of x is here 1, and derivative of constant that is 3, its derivative will be what? 0. Derivative of constant function 3 will be 0. And here here derivative of y with respect to u will be 8 times u power 7. Here I am using x to n and x to n minus 1 formula. Okay, so on the place of x we have just u. So therefore we got du upon dx as 2, and dy upon du we got 8 u power 7. So chain rule is what? Chain rule, our rule says that, okay, our rule says that, chain rule says that uh, dy upon dx you can write dy upon du into du upon dx. So dy upon du we have 8 u raised to 7, and du upon dx is 2. So it is total equal to 8 to the 16, 16 u power 7. But u is, in the initially what we have assumed u as 2x plus 3. So it will be 16 2x plus 3 power 7. Okay, I hope you have understood this method. You have understood the chain rule. This we are writing with the help of chain rule. Okay, now let's see another example. This is little bit of different kind. Suppose you have a function whose value is written in the form of it is written in the 2x square minus 1. Okay, in this case let assume the inner part that is u 2x square minus 1, take it as u, and when you will consider 2x square minus 1 as u, then your y will become root of u. We know that derivative of root x is what? 1 upon 2 root x. Therefore in this case derivative of root y will be basically 1 upon 2 root y. Okay, so for this I am telling this. Now differentiate u with respect to x, and differentiate y. We will differentiate y with respect to u, because y is written in the form of u and u is written in the form of x. So here its derivative du upon dx will be 2 is coefficient, derivative of x square is 2x, and constant number 1 is constant number, and whose derivative will be 0. And here y dy upon dx will be what? Square root of, okay, y we are differentiating with respect to x, therefore dy upon it will be du. Okay, it will be 1 upon 2 root u. Okay, by chain rule by chain rule dy upon dx will be dy upon du into du upon dx. So we have dy upon du is 1 upon 2 root u into its derivative. So here derivative 2 2s are 4, we got 4x. So here it is 4. Now substitute original value of u. So u is originally 2x square minus 1. This is 1 upon 2 times square root of 2x square minus 1 and into 4x. We can cancel, we can cut this. Okay, so this will be 2x upon square root of 2x square minus 1. Okay, so let's see one more example, and chain rule is only this much. Let's see one more example. This will be little bit I can say this will be little bit complex. So let the third one y, suppose y you have given in the form of 6 upon cube root of 2 minus 3x. Okay, so this part is looking different. Take it as u, basically u, then u will be what? 2 minus 3x, and therefore y will look like 6 upon cube root of u. Okay, Now simplify by, it will look like how? 6 upon u raised to 1 by 3 using law of indices. Therefore, y will look like 6 into u raised to minus 1 upon 3, as 1 upon a raised to n is what? A raised to minus n. And okay, so now we can differentiate both of this. So differentiate here, differentiate with respect to differentiate u with respect to x, and here we will differentiate y with respect to u. So here in this case it will be du upon dx, and 2 is constant function whose derivative will be 0, minus 3 times derivative of x is what? 1. So we got derivative of u with respect to x as minus 3. Here we will derivative of y with respect to u will be 6 is coefficient derivative, and its derivative we will find out using this formula. So x raised to n is n x raised to n minus 1. Here x, on the place of x we have u, and on the place of n we have minus 1 by 3. So it will be n, that is minus 1 by 3. Okay, and x, on the place of x we have u raised to minus 1 by 3 minus 1. Okay, so we know that minus 1 by 3 minus 1 is nothing but minus 1 minus 4 upon 3. So it is minus 5 upon 3. So on the place of minus 1 by 3 minus 1 we will write minus 5 upon 3. So this is basically this will be equal to 3 2's are, we can cancel this also. So this is minus 2 times uh, u raised to minus 5 upon 3. Okay, now you can write minus 5 upon 3 u raised to minus 5 upon 3 as u raised to minus 1 by 3 power 5. Okay, this is just I am simplifying. Okay, this is what I am simplifying it. So this will be basically, you can write 1 upon, this is cube root, so 1 upon cube root you can write here. Okay, cube root, and then you can write overall power 5. In this way also you can write it. Okay, so instead of writing this I will prefer to write this format. So it will be minus 2 times 1 upon cube root of, I can say cube root of u and overall power 5. Okay, now apply chain rule. Apply chain rule here. So chain rule is basically dy upon dx will be dy upon du into du upon d du upon dx. So here this is basically minus 2 upon, this will be cube root of u, and this was power 5 because we can write it minus 2 upon cube root of u power 5. So here I am writing, and into derivative of u with respect to x is minus 3. So overall we got minus 6 upon, okay, minus 6 upon, and this can be written as this because cube root we have and here power 5 we have. So we will get 1 6 minus minus plus 2 is a 6. Here it will be u, and it will be q uh, it will be cube root of u square. This is your final answer. Okay, thank you so much for joining our video, for joining us in the next. Now we will meet into the next part. Thank you so much.